Okay, so today we're going to be converting polar equations. So we already converted polar coordinates, and we went over that these are 4 formulas that you do need to memorize, and they come up when we have to convert our polar equations either from rectangular form to polar equations or polar to rectangular, as this first one is mentioning. Okay. This note is very important as you take down your notes. If the conversion from polar to rectangular is complete, there should be no r, no theta, and your rectangular equation should be written in standard form. So you should be familiar with the standard forms of equations, whether it's a parabola, a circle, etc. Okay, so keep that in mind as you're working on it. That means that you're either going to get like an x equation, a y equation, y in terms of x, maybe with squares, who knows? Okay? And this is kind of like a puzzle. How can we get from one to the other? I'll erase some more so it's a little bit clearer here. Okay, so for example, we see that we have this polar equation. So r is 4 secant of theta. Okay, so if you look at our equations that we have here, we have a few of them that associate r and theta together. Okay, it's this equation and this one. If I try to use the other equations, let's say first this one, our circle, and I substituted 4 secant of theta and squared it. Hold on, that's an equals. I wouldn't get anywhere because if I square this, I'm still not getting rid of, I forgot to square that. I'm not getting rid of that theta. This is a problem. Okay, that should not be here. These are okay, but there isn't a way for me to get rid of theta here. Unless I start solving for theta from here in terms of x and y, but then it wouldn't be in standard form, and you know that. This is not acceptable. So, at this point, okay, I'm extremely stressing that that's not what we should do. Okay, maybe it would be for a different problem, but not this one. So going back, a strategy we can use is see what we are working with and what we need to change it to. So r squared is equal to x squared plus y squared did not work because we didn't have r and theta with it. Okay? So now we do have, once again, going back, our x and y equations. And they do have r and theta. So in these equations, okay, it's not r by itself like the given problem. So if I were to solve for r here, I'd have x over cosine of theta. And r is then x secant of theta. And so this kind of matches with what we have in our example. Now, although we didn't realize it before, okay, we have that x must be 4. It seems like a solution, but if you remember, this is a standard form of a vertical line. And we just converted our equation into rectangular form. So sometimes we think it may be useful to go one way, but try it out and see what happens. In the end, it's got to be something we know in standard form. And in the middle, we have to make sure that we are getting rid of the variables we want to get rid of. Okay? So there we have it. There's our conversion from our polar equation into a rectangular one. So we're going to do the opposite of this. So let's take a look at our next example. Okay, so once again, we're using these to kind of solve our riddle. It is like a riddle. So the other thing you need to make note is that we are working with changing from rectangular to polar. So no more x's, no more y's. Some things should be like r equals, some things should be theta equals. R should be something in terms of theta, if at all possible. So let me erase this and let's get started. So for this equation, it's just y is equal to 2. So it's not a good idea to use this equation because there is no y whatsoever. And with these equations, you also need an x. So we're going to use this one. And so I'm going to replace the y with 2. And you can see how it's r in terms of theta. Well, it's not r in terms of theta yet. But it is a polar equation because there's just an r and a theta. There's no x, there's no y. So now our goal, if possible, is to get r by itself. And we can if we divide both sides by the sine of theta. And using our trig identities, this is 2 cosecant of theta. So we just change our rectangular equation over into a polar one. Okay? Sometimes we have equations like this. Okay, we need both of these. Okay, sometimes we're given something like this. We just need that. It depends on what's given to us. Take a look at what you have, what you need. And so that's why I said in the last slide and in this slide, this is very important to know what you need. So that way you can get there. And good luck.